Hello guys, how are you all? I hope you all are fine. So once again you are very welcome in a lecture number 7 of circles. Okay, so my dear friends, in this lecture again we are going to see some theorems. Okay, yes, so now let's start without wasting the time. Yes, so today we are going to discuss the angle subtended by a diameter on the circle. The angle subtended by diameter on the circle. Okay, so now here is let's see the theorem 10.12. So this theorem states that the angle subtended by a diameter, the angle subtended by a diameter or semicircle on any point of circle is 90 degree. Okay, let's suppose we have a circle like this. Okay, and in this PQ is what? PQ is the diameter. PQ is the diameter. Okay, so angle subtended by the diameter. So which angle? So we are talking about this angle. So this angle is subtended by the diameter PQ, diameter PQ, or this angle is also subtended by this semicircle also. This semicircle. This semicircle. Okay, so this angle is what? This angle is 90 degree. This angle is 90 degree. Okay, now now let's prove that this angle PAQ is 90 degree. Okay, so now here is, first of all we have to write the given path. Okay, so we have a circle with center at O. Okay, and we have PQ, which is the diameter. So PQ is the diameter of circle. PQ is the diameter of circle. Okay, subtending angle PAQ. Okay, subtending angle PAQ at a point A on circle. On what circle? And here we have to prove that here is angle PAQ. This is equals to what? This is equals to, yes, 90 degree. Okay, we have to prove this. So now let's start the proof of this theorem. Okay, now here is, now POQ, this is what? This is a straight line. POQ is a straight line which is passing through the center O. So we can write POQ is a straight line. It is a straight line which is passing through center O. Okay, so angle subtending by arc means the angle subtending by arc PQ means this arc. This is the arc. So angle subtended by arc PQ at O is 180 degree. This is what? 180 degree. So we can write, so angle subtended by arc PQ at O is what? Is, yes, so angle POQ is equals to 180 degree. Let's suppose this is equation 1. And we know that by the theorem 10.8, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, my dear friends, so we can write here as thus, angle POQ is equals to, okay, so angle POQ is equals to twice of angle PAQ, means we are talking about this theorem. So this is by theorem 10.8. Okay, and we know very well. Okay, now so angle PAQ will become half into angle POQ, and from equation 1 we can write half into angle POQ is 180 degree. Okay, from equation 1. Okay, now my dear friend, this will become angle PAQ is equals to 90 degree. Angle PAQ is 90 degree. So we can write hence proof. So I hope, my dear friends, I hope you understand these things. Okay, so this is the proof of this theorem. Okay. Yes, so now my dear friend, let's move on. So here is, now we are going to see the next theorem. So this theorem states that if a line segment joining 2 points subtend equal angle at 2 other points lying on the same side of the line containing the line segment, then the 4 points lie on the circle, that is they are concyclic. So here is, you can see that, now let's suppose we have a circle like this. Okay, so here is, and we have a line AB. Okay, now with the help of this line, the two angles are subtended, which is angle C and angle D, and these two angles are what? These two angles are equal. Okay, so now my dear friends, these 4 points lie on the circle. We have to prove this. Okay, so here is, first of all we have to write the given part. Okay, yes, so now A, B, C and D are 4 points. Okay, now AB subtends equal angles at C and D, means AB subtend equal angle at C and D, that is angle ACB is equals to angle ADB. Okay, I hope you get this point. So now we have to prove A, B, C and D. A, B, C and D are what? Are concyclic. Means these 4 points lie on the circle. Okay, now let's start to prove this theorem. So here is, so my dear friends, in this theorem, since A, B, C are what? Are non-collinear, we know that. So we know that A, B and C are non-collinear. Okay, and we know that one circle passes through 3 non-collinear points. Okay, we know that from the 3 non-collinear points we can draw one such circle. Okay, now let us draw a circle C1. Now let's suppose this is circle C1 through the points A, B and C. Okay, now let us assume that D does not lie on the circle C1. So we are assuming that D is lie outside the circle. Okay, now let circle intersect AD. Let the circle intersect AD at D dash. Okay, so here we can write, let us assume D does not lie on circle C1. Okay, so let circle intersect AD at D dash. Okay, at D dash. Now we know that angle ACB is equals to angle AD dash B, because we know that angles in the same segments are equal. Okay, here is, you can see that angles in the same segments, this segment. angles in the same segments are equal. So we can write angles in the same segments are equal. Got it, my dear friends? So let's suppose this is equation number 1. Let's suppose this is equation number 1. But given we have angle ACB is equals to angle ADB. Okay, so this is what this is given. And let's suppose this is equation number 2. Okay, so from first and second equation, here is you can see angle ACB is equals to angle AD dash B, and angle ACB is also equals to angle ADB. So we can say that angle AD dash B is equals to angle ADB. Okay, so we can write from equation first and from equation second, we can write angle A D dash B is equals to angle A D B. Let's suppose this is equation number 3. This is equation number 3. Now in triangle B D D dash, means in this triangle, you can see in triangle B D D dash. Okay, got it? So angle A D dash B is equals to, this angle is what? This angle is exterior angle. So this is equals to angle B D D dash plus angle D dash B D. Means we know that by the exterior angle property. Exterior angle property. Got it? So here is you can write as angle A D dash B. We know that angle A D dash B is equals to angle ADB. Okay, so we can write here is angle ADB in place of angle AD dash B. Okay, so angle ADB is equals to, here is, now you can see, now this angle BDD dash, means angle BDD dash, we can write this angle ADB. This is the same thing. Okay, so we can write also angle ADB plus angle D dash BD. Now you can see this angle and this angle will be cancelled. So here we can write angle D dash B D is equals to 0. Angle D dash B is equals to 0. Okay, so from this we can say that D dash and D, these 2 points coincide, thus our assumption was wrong. Means we are assuming that D point is not lie on the circle, it is lie outside the circle. So this assumption is wrong. So we can say point D lie on the circle. It means A, B, C and D are concyclic points. A, B, C and D are concyclic points. Okay, so we can write D dash and D coincides. Okay, so our assumption was wrong. So we can say point D lies on circle. It means we can say A, B, C and D are concyclic. Are concyclic, we can say, and proof. Okay, my dear friends, I hope you understand these things. Yes, so now let's move on. Yes, so now my dear friends, here we are going to solve some problems. Okay, so if diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, then prove that it is a rectangle. Then prove that it is a rectangle. Okay, so now here is, first of all, we have to write the given part. Okay, so we have, let A, B, C, D be a cyclic quadrilateral. Be a cyclic quadrilateral. Okay, cyclic quadrilateral where diagonal AC, diagonal AC, here is, you can see in the figure, this diagonal AC and the diagonal BD are the diameter of the circle. Diagonal AC and diagonal DB are what? Are the diameter of circle. Okay, yes. So now, and we have to prove, here is, we have to prove ABCD is a rectangle. ABCD is a rectangle. Okay, so now my dear friends, here is a rectangle is what? A rectangle is a parallelogram with one angle is 90 degree. We know that very well. Okay, so we first prove ABCD is a parallelogram, then one angle is 90 degree. Okay, so first of all we have to prove that ABCD, okay, ABCD is a parallelogram. Okay, then we have to prove that one angle is 90 degree. Okay, yes, so okay, so here is, let's start. So now, first of all, here we can write, first of all, we have to prove that a rectangle, we know that a rectangle is a parallelogram, okay, with one angle is 90 degree. One angle is 90 degree. So we have to prove ABCD is a parallelogram. So first we have to prove that ABCD is a parallelogram. Then one angle is 90 degree. Okay, so now here is, let's start. Since we know that since BD is a diameter, BD is a diameter, here you can see this BD, we are talking about this BD is a diameter. Okay, so BD is what? This is a diameter. Now arc BAD, here is BAD, means we are talking about this arc. Now this arc BAD, okay, is a semicircle. This arc is the semicircle. So arc BAD is a semicircle. Okay, and we know that the angle subtended by the diameter or by the semicircle at any point of the circle is what? This is 90 degree. Okay, so here we can write that angle BAD is equals to 90 degree. Angle BAD is equals to 90 degree. Okay, so this is by what? By theorem. Okay, we already proved that in the previous theorem. Okay, I hope you understand these things, my dear friends. So now here is, now since similarly here is AC is the diameter. AC is what? AC is the diameter. Okay, and arc ABC means this arc. Arc ABC, it means we can say that this angle ADC is 90 degree. Angle ADC is 90 degree. So we can write similarly here is, we know that. Okay, so AC is what? AC is the diameter. So here is arc ABC is a semicircle, is a semicircle. Okay, so this arc, we are talking about this arc A, B, C. This is what, this is the semicircle, and AC is the diameter, and we know that the angle subtended by the diameter or the semicircle, okay, at any point of the circle is what, 90 degrees. So this angle is 90 degrees. So we can say that, so angle ABC is 90 degree. We can write the reason. Angle in a semicircle, angle in a semicircle is a right angle, is a right angle. Okay, yes. So now here is, also we know that ABCD is a cyclic quadrilateral, is a cyclic quadrilateral. Okay, ABCD is what? ABCD is a cyclic quadrilateral, and we know that the sum of opposite angles of cyclic quadrilateral is 180 degree. So we can write, so sum of opposite angles, sum of opposite angles of cyclic quadrilateral is what, is 180 degree. This is 180 degree. So we can write here as angle BCD plus angle BAD is equals to 180 degree. Okay, and here is angle BAD, we know this is 90 degree. So we can write angle BCD plus, here is, we already proved angle BAD is 90 degree. So we can write this is 90 degree is equals to 180 degree. So we can find that angle BCD is 180 minus 90, we get 90 degree. Okay, here is angle BCD, means this angle is 90 degree. Similarly here we can also find angle, we have angle ABC plus angle ADC. This angle ABC plus angle ADC means this angle and this angle is equals to what, 180 degree, is equals to 180 degree. And we know that angle ABC is 90 degree. So we can write 90 plus angle ADC is equals to 180 degree. So from this we can write angle ADC is equals to 90 degree. Okay, so now the angles of these cyclic quadrilaterals, all the angles are what, 90 degree. Okay, so we can write, so in quadrilateral A, B, C, D, angle A is equals to, angle B is equals to, angle C is equals to, angle D is equals to 90 degree. What is? Yes, all the angles are 90 degree. Okay, now my dear friends, here is, since angle A is equals to angle C and angle B is equals to angle D, this is the property of parallelogram, because we know that in parallelogram opposite angles are equal. You can see angle A is equals to angle C, both angles are 90 degree, and angle B is equals to angle D. So here we can say that is both pairs of opposite angle, both pairs of opposite angles are equal, are what, are equal. So we can say A, B, C, D is a parallelogram. ABCD is a parallelogram. Also all angles are 90 degree. Also all angles are 90 degree. So we can say, so ABCD is a parallelogram with one angle 90 degree. Okay, therefore ABCD ABCD is a rectangle. ABCD is a rectangle. Okay, and we can write hence proof. I hope my dear friend you understand these things. So this is the proof of this question. Okay, yes. So now let's move on. So here is, so the next question is, if the non-parallel sides of a trapezium are equal, it means this AD and CB, these are the non-parallel side of a trapezium, so these sides are equal. It means we can say that this is what, this is isosceles trapezium. Okay, and prove that it is a cyclic. Okay, it means we have to prove that ABCD is a cyclic quadrilateral. Okay, yes. So now here is, first of all, we have to write the given part. So now in this we have ABCD, which is a trapezium. So ABCD is a trapezium. Okay, where AB is parallel to DC. We know that in trapezium one pair is parallel, one pair of opposite sides is parallel, and one pair of opposite sides is non-parallel. And you can write non-parallel sides are equal. It means that is AD is equals to BC. Here is this AD is equals to this BC. Okay, and here is we have to prove, it means prove that ABCD is a cyclic quadrilateral. Okay. Yes, so now first of all we have to do a construction in this. So we have to do construction. Okay. So what is the construction? Let's see. So here is, you can see in this, we have to draw DE, which is perpendicular to AB. Okay, and CF, which is also perpendicular to AB. So here we can write, draw DE, which is perpendicular to AB, and CF, which is also perpendicular to AB. Okay, and now let's start. So we are going to start the proof of this problem. So here is, to prove ABCD the cyclic quadrilateral, we have to prove that, first of all we have to prove that sum of one pair of opposite angle is 180 degree. Sum of one pair of opposite angle is 180 degree. Okay, so here we can write, to prove ABCD is a cyclic quadrilateral. To prove ABCD is a cyclic quadrilateral, we prove that sum of one pair of opposite angles, sum of one pair of opposite angles is 180 degree, because we know that this is the property of cyclic quadrilaterals. Okay, I hope you understand these things. So now here is, now in triangle ADE, here you can see we are taking this triangle. Okay, this is triangle ADE, and triangle BCF means this triangle. So triangle 1 and triangle 2. Okay, in triangle ADE and triangle BCF. Okay, so angle AED is equals to angle BFC, is equals to angle BFC, because here is, you can see this angle and this angle, these two angles are 90 degree. These two angles are 90 degree because AE is perpendicular to AB and CF is also perpendicular to AB. So now my dear friends, here is also AD is equals to CB. This is given in the question. This is given in the question. Okay, and DE is equals to CF because distance between parallel sides is equal, means we know that DC is parallel to AB, so the distance between these two parallel sides is equal. So we can write distance between parallel sides is equal. Okay, so we can say triangle ADE is congruent to triangle BCF by what? By RHS rule, means one right angle, one hypotenuse and one side. Similarly, one right angle, one hypotenuse and one side. So we can say that these two triangles are congruent by RHS rule. So here is, you can see, we can write that angle DAE means this angle is equals to angle CBF by CPCT, corresponding parts of congruent triangle. It means, that is, we can say that angle A is equals to angle B. Okay, now let's suppose this is equation number 1. Now for parallel lines AB and DC. Here is AB and DC. Okay, with transversal AD. Okay, for parallel lines AB and DC with transversal AD. Okay, we can say that angle A plus angle D is what? 180 degree, because interior angles on the same side of transversal are supplementary. Okay, so here we can write as for parallel lines AB and DC, and AD is the transversal line. Okay, so we can write angle A plus angle D is equals to 180 degree. Okay, and we know that angle A and angle D are what? Yes, interior angles, and the sum of interior angles is 180 degrees. So we can say that they are interior angles. Got it? So here is from equation 1, we know that angle A is equals to angle B. So we can write angle B in place of angle A. Okay, and angle B plus angle D is equals to 180 degree. We can write from equation first. Okay, and we can see that here is angle B plus angle D, and these two angles are what? Opposite angles of this quadrilateral. Okay, so in ABCD, sum of one pair of opposite angle is 180 degree. Therefore, we can say that ABCD is a cyclic quadrilateral, and hence proof. We can say hence proof. So we can write, so in ABCD, sum of one pair of opposite angles is 180 degree. Okay, so therefore ABCD is a cyclic quadrilateral. Okay, and we can write here is hence proof. I hope, my dear friend, you understand these things. Okay, yes, so now let's move on. Yes, so now, my dear friends, so the next question here is, now if circles are drawn taking two sides of a triangle as diameter. Okay, now let's suppose we have a triangle ABC. Okay, and with the help of these two sides, let's suppose this is AB and BC. We are taking these two sides AB and AC. Okay, with the help of these two sides, we are drawing two circles, circle C1 and circle C2 as AB is the diameter of circle C1 and AC is the diameter of circle C2. Okay, now here is we have to prove that point of intersection of these circles lie on the third side. It means here is, let's suppose we have point D. So this point is what? This point is on the third line, means is on the BC, and this is the intersection point of the circle C1 and C2. We have to prove this condition. Yes, so now let's start. So first of all, we have to write the given part. Okay, so what is the given part? So you can see here is, okay, we have a triangle ABC. Okay, now since AB, we know that AB is the diameter of circle C1, so we can write AB is the diameter of circle C1, and AC is the diameter of circle C2. Got it? Understand? And here is point of intersection of C1 and C2 is A and D. Point of intersection of C1 and C2 is A and D. A and D. Okay, so now we have to prove, here is, we have to prove point of intersection lies in third side. It means that is point D lies on BC, means this point D lies on BC. Okay, yes, so now here is, we have to do a construction here is, so the construction is what? So the construction is, we have to join AD. Let us join AD. Okay, so this is the construction part. Let us join AD. Got it? Now let's start the proof. Yes, so now my dear friends, we know that in circle C1, here is C1, since AB is the diameter, AB is the diameter, we know that AB is the diameter, and we know that here is the arc, this arc ABD. Which arc? This arc. We are talking about this arc ABD. Okay, so arc ABD is what? It is a semicircle, so angle in the semicircle is a right angle. Angle in the semicircle is a right angle by the theorem, so we can write here as arc ABD is a semicircle. Is what? It is a semicircle, so angle ADB is equals to 90 degree. We can write angle in a semicircle. Angle in a semicircle is a right angle. Okay. Now similarly in circle C2. Okay, in circle C2, AC is what? AC is the diameter. Okay, so this arc A, D, B. This arc. This arc is what? This arc is semicircle. Okay. So here is we can write arc ADC is a semicircle. Is a semicircle. And we know that angle in the semicircle is a right angle by the theorem. So angle ADC is equals to 90 degree, and we can write angle in a semicircle. Angle in a semicircle is a right angle. Is a right angle. Okay, got it, my dear friends? So it means this angle and this angle is what? This angle is 90 degree. Okay, now angle ADB plus angle ADC is equals to 90 plus 90. Okay, so this will be 180 degree. So since the sum of these angles is 180 degree, it means they form a linear pair. So we can write, since the sum of angle is what? Angle is 180 degree. So we can say here is they form a linear pair. They form a linear pair. Okay, and linear pair can only happen on a line. Can only happen on a line. It means we can say that this point D lies on the line BC. So therefore we can say that BDC is a line and D lies on the line segment BC. Okay, so here we can write linear pair can only happen on a line. Can only happen on a line. Therefore BDC is a line. It means D lies on the line segment BC, which is the intersecting point of C1 and C2. So we can say that hence proof. I hope, my dear friend, you understand these things. So this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.